Hello. So let's go through your holiday homework. Number 2, week 2 answers. So you should have already done or attempted the questions. Now it's just merely looking through the solutions and figure out what went wrong and learn from your mistakes. Okay, so let's take a look at the question 1. Oh, period. Period is basically your time taken to complete one oscillation. Complete oscillation. Then you might be thinking, what in the world does a complete oscillation means? So a complete oscillation is actually from X, Y, Z. So it is from X to Y, Y to Z, Z to Y, Y to X. Essentially one whole round lah. Essentially it's like you're running on a track. You have to go one whole round back to the same spot, essentially. So in this case, what sequence should be timed to measure the period? Ideally, we will say X to Y, Y to Z, Z to Y, Y to X. But in this case, I can actually simply choose the answer of X to Z, Z to X. So the answer is this, X to Z, Z to X. So the answer is donkey. Okay, next. So this is a distance time graph, okay? Then you see the word acceleration speed. Oh no, panic. Don't need to panic. So recall that the gradient of the graph is y-axis divided by the x-axis. In this case, distance divided by time, which you remember as speed. Oh, speed. So you see common factor, radian, speed. Okay, so let's take a look. At point actually D, look at D first, because D literally has the word speed. So at point S, okay, let me use the colors. So at point S, so that we can see that distance remain the same. Because from point S onwards is a straight line. If the distance is the same, it doesn't travel any more distance. Doesn't that mean that it is at rest? So this is wrong. I mean, technically you can argue, at rest means constant speed of 0. But if it's at rest, we'll just say 0. We don't say constant speed of 0. A bit odd lah. Constant speed means speed is not equal to 0. It's equal to a number. Let's say I'm traveling at 10 meters per second. That's a constant speed. Not 0 meter per second. That is just at rest. It's not moving at all. There's no speed to talk about. Okay, next one, let's take a look at P. So option, I change color. Red color, option A. Oh, what we can see here is the distance traveled is essentially increasing. So speed here is, so you see the gradient. The gradient here is getting, the gradient, okay, let me write down. The gradient is increasing. How do you tell that? Because the curve getting steeper. And remember, what does the gradient mean? Gradient means speed. Oh, so gradient increase means speed increase. Speed increase, that means accelerating, isn't it? So the word decelerating is wrong. So A is wrong. B, use a different color, green. At Q, we can see that the distance is increasing, but in this case we will say that it is actually a constant speed. Why? Your gradient is the same, isn't it? Gradient is same because it's a straight line. Gradient same means speed same. Speed same is constant speed. It is not constant acceleration. Therefore, the answer is C. Because look at your R. Let me use another color, purple. At R, we can see that gradient is decreasing. Means, how do you know gradient is decreasing? Because the curve is getting gentler or less steep. Less steep means speed is decreasing. That means we call this deceleration or slowing down lah. Hence answer is C. Cool. Okay, question 3. So if you recall, for a wheel or for a circular object, the friction force is the same direction as the movement. So in this case, D is the answer. Yep. But why is that so? Because you see, your wheel is actually rotating. Your wheel, so it's moving to the right. That means the wheel is technically moving this way. Can you see my arrow here? So it is technically, so I try and draw this way, which means friction is the opposite of the direction. Therefore, friction is here. This is wheel, the direction of the wheel. Or simply put it, whenever there's a circular object, the friction is the same direction as the object, wherever the object is moving. Simply put it. Okay, question 4. Mass and weight. So formula W equal to mg. We remember that mass basically is scalar. Means there's no direction. Also, mass does not change. I don't care. Basically, I am 85 kg. That's my mass. I go to moon, I go to Jupiter, I go to sun, I go to earth, whatever, I still remain 85 kg. But what will change is the weight. Because G changes. So at certain planet, I'll feel lighter. But doesn't mean my mass change. Okay, so what is given here is... so let's just calculate. So W mass is just 15 times 3.7. 15 times 3.7 equal to 56 Newton. Then W earth, 15 times 10, 150 Newton. So answer is 100 and... oops. I just need mass. So mass is 56 and 15A. Yep. Okay, next. Chair is 50 Newton. Okay. Pressure. So P equal to F over surface area. So in this case, the 50 Newton, yes, but each area is this. So isn't it just 50 divided by 0.002 times 4? Why? Because 4 legs. 4 legs. You get the answer of 6250 Pascal. Hey, yay. Okay, next, let's move on to this question. So, explain why P must be greater than 1 Newton for the crate to accelerate. Why is that so? So let's think about it. Why is that so? So, okay, well, what we can see here is this. Friction is 1 Newton to the left. So if your force, okay, it says why it must be greater than 1, right? So let's say it is 1. So let's say P is 1 Newton to the right. If you have 1 Newton to the left, 1 Newton to the right, it cancels out. So your resultant force in this particular scenario is 0. Your crate still doesn't move. So now, okay, when there is acceleration, that means that there is a resultant force. So the answer here is so that there will be a resultant force acting, a resultant force on the crate to the right. Okay, next one, B. So let's read carefully. They say using P equal to 6 Newton in the figure. So let's look at the figure. So 6 Newton. 6 Newton is here. So you extrapolate. Okay. It seems like this is 1.25. So that means the acceleration is 1.25. So what can we, so your P equal to 6.0 Newton. This means that A equal to 1.25. How do you know this? From graph. Okay, cool. So F resultant equal to MA. So you want to find M. So M equal to F over A equal to 6.0 divided by 1.25. Don't get caught. You see, what exactly is the, wrong color. What is the resultant force? So if it is indeed 6 Newton to the right and 1 Newton to the left, the resultant force is 5. Yep, so must be careful. So this is 5. So you get the answer of 4.0 kg. 4.0. 2SF, remember? Your 2SF. So what happened when P is now 1? It's basically this scenario, isn't it? Oops. So we have to write it down. So what happens? We'll say that P is equal means the strength. It is basically a magnitude. Basically your magnitude. And opposite is basically talking about direction. To what? To the frictional force. In other words, they cancel out, which means there is no resultant force acting on crate. Cool, yay! So that will give you your first mark. Because why? You talk about the forces already, but have you talked about what happened to the crate? No, they don't have. So what should you be telling them? So if your crate is already moving. Oops, my mistake. If your crate is already moving, your crate will continue to move at constant speed. Why? F resultant equal ma. If a is 0, if 0,000 force is 0, a is 0, it doesn't accelerate. So same speed. But if your crate is at rest, it's not moving, that means the crate will continue to at rest. Be at rest. Okay, this is extra, don't need. Because why? The question already say already, it's moving. Then now I reduce the force. But this segment is just for you in case you wanted to know more. Yep. Alright. Okay, next segment would be... Next question is your torture tool. Okay, let's take a look. So what does it mean by center of gravity? It is basically a point. So you want to get a point, you need to write down a point. What is this point? A point where the whole weight of the object seem or appear to act on or act on. After which they say draw and label a possible position of the weight in order to balance it. So where should it be? So this question did not say anything about uniform. So where could it be such that it is balanced? It will be weight of your tool. Alright. Okay, so it says hence calculate the distance of your center of gravity to the pivot. Meaning you need to calculate. So you see, there is a word here that I think is important. The tool can be balanced when there is no victim. No victim, nobody, nobody. So when there's nobody, essentially the forces are your weight of the stone and the weight of the tool, because there's nobody sitting on it. Read carefully, don't panic. So when you see the word balance is telling me that we can say this taking moments about the pivot or in other words, principle of moments. It's basically principle of moments. So when do you need to use these principle of moments? When either they have the word principle of moments, or you see the word balanced, then you know that you have to use this particular thing. What is this thing? This thing means the total anti-clockwise moment equal total clockwise moment. So in this case, your clockwise moment is the one in red, right? Your stone. Which in this case is your, so recap, your moment equal to F times perpendicular distance. So your F is, they say that it is 100 kg. 100 times 10. This is your weight. Okay, weight of stone times 2.0. The anti-clockwise moment, you will get the distance. I don't know what's the distance. That's what we're trying to find. Times 120 kg times 10, which is the weight of the tool. So D would be equivalent to 1.67 meter, which is approximately 1.7 meter to SF. 1.7 to SF. Yay, cool. Next, now the victim is present. The tool start to rotate anti-clockwise. What can you do to keep the tool horizontal? Well, you can do two things basically. You can either shift the stone to right side of the plank, or you can change your stone to a heavier stone. Or add more stone. So this one is 1 mark. Either 1 mark. The second one is explanation. So what's the explanation? It's essentially called is to increase the clockwise moment. Because why? You got more anti-clockwise, you add more clockwise, you can balance it lor. Okay, second last question. Let's take a look at the next part. Oh, your GPS, energy in GPS. So your energy in GPS is essentially, you recall, the two formulas that we care about is energy in GPS is mgh. Energy in kinetic store, gravitational potential store, and kinetic store is half mv squared. Quite standard one. So your energy equal to GPS equal to mgh. Throw the numbers in. 65 times 10 times 15 equal to 9750 joule. Oh, yeah, that's about it. 9750 joule. You want to continue and give me 9800 joule 2SF, also not a big deal. Next one, hence or otherwise determine the speed. So this is using your principle of conservation of energy, which is what? You cannot destroy energy, you cannot create energy, you can only convert. Principle of conservation of energy. Basically, your energy in your GPS equal to the energy in KS. So mgh equal to half mv square. Then what happened? 9750 equal to half times m. M is 65 times v square. So v equal to 17.3, 17 meter per second, 2SF. 17, 2SF. Yes, so which store is it transferred from and to? So it is basically your GP, gravitational potential store, and kinetic store becomes your elastic potential torque. Yep, and the last question. Okay, let's take a look at the last question. So you're on a straight level track. The maximum speed of car A. Isn't it just 50 meter per second? You just read off the graph lah. Lol. Maximum 50, 58. 3 mark. Describe the motion. It's something that they love to test. So you need to talk about speed. And you need to talk about acceleration. That's what usually we expect, right? So let's take a look. So now they're asking for last 2.5 meter of B, which is just this drop. Oh, okay. So you say that the speed decreases from 30 meter per second to 0 meter per second. What about the acceleration? We can say that it is a constant negative acceleration. Or constant deceleration. That's it. Okay, next one. You cannot use formula here because question forces you to use the graph. Distance. Okay, again, don't panic. So gradient equal to y-axis divided by x-axis equal to speed divided by time equal to acceleration. Okay, cool. Area under the curve or area under the graph is your y-axis times x-axis equal to speed times time equal to distance. This is the one that is relevant here. Okay, so I need to find the area under the graph for distance of B. Sure. So, and also read carefully. First 10 seconds. So you're essentially just looking at, wrong color. First 10 seconds, essentially just this. So you're supposed to find the area of a triangle. That's not difficult. It's just half times base times height. Sounds familiar? So 10 times half times 30 equal to 150 meter. Cool. Last two parts from 10 second to 37.5 seconds. Car is traveling at constant speed. Very simple. Constant speed means acceleration equals 0. F resultant equal to ma. If a 0, F resultant 0. So 0 Newton. Cool. And the very last one. Accelerating force. Isn't it got to do with acceleration? So which one is greater acceleration? So looking back, I use another purple acceleration. Greater acceleration. Doesn't it just mean gradient? So you see for yourself lor. Which one got a steeper gradient? A lah. A got steeper gradient mah. You tell them, that's the answer. So car A. Why is that so? Because it has the larger gradient. Of course, don't stop there lah. What in the world does gradient mean? Tell me. Larger gradient. And gradient in this case is the acceleration. Equal acceleration. So larger gradient means larger acceleration lah. Oh, cool.